less chatty than their other toothed whale cousins like orcas or dolphins. So just keep your eyes peeled on that while we talk about what makes Dobbs Glacier so incredible. Now, it is a tidewater glacier. It is about a little over a quarter mile wide, 300 feet of ice above the water and 300 feet of ice below the water. And from the Stikine ice field where Dobbs Glacier flows from, it's a 20-mile flow. So 20 miles back, that's how far this glacier goes. And the Stikine ice field itself has over 2,500 square miles of glacial ice. Probably the most commonly asked question about the glacier is, why is the ice so blue? Well, that is because of the density of the ice. Ice that you get from your freezer is about 70% air. That's why it's white and cloudy, only 30% water. But glacial ice is 90% water, only 10% air. At that density, crystalline structures form and it acts as a light prism. As colors like red, yellow, and orange pass through with their higher wavelength, they're absorbed. But blue, with its shorter wavelength, is able to pass through and refract to our eyes, and that's what gives us that beautiful blue color. As ice falls off of the glacier, it'll lose its density, oxygen will become more exposed to it, and that's why you see more cloudy bits of ice in the water here now that it's off the glacier. But how does it get so dense in the first place? Well, it all happens in the accumulation zone of the glacier, which is the ice field. In this case, it's the Stikine ice field. Layers and layers of snow will fall on top of the ice field, and after the course of the year, it'll squeeze air out and become a dense ice called firn. Then more snow will fall on top of the firn and squeeze even more air out, and then it'll become glacial ice and get that blue color. But fun fact for you folks, it takes 100 inches of snow over 100 years to make 1 inch of glacial ice. So what you're seeing is quite the product of natural history. Thousands and thousands of years and thousands of inches of snowfall. But the journey doesn't stop there, folks. When that becomes glacial ice, gravity is going to be pulling that ice forward, because these glaciers, they're like frozen rivers. They're constantly moving. Also at our about 4 o'clock, a few harbor seals perched up on some ice there, in case you haven't seen any harbor seals swimming around. But gravity's going to be pulling the ice forward. Then we're going to see calving events like we saw today, where seawater is weakening it, air is weakening it, gravity's weakening it, become large icebergs in the water, and then they'll melt down to Berkey bits. Then they'll get small enough for me and Wyland to get in a fishing net, put some ice in your glacierita, and then it'll be gone. But from start to finish, folks, that ice that's in your cup, that ice that you've been holding, taking pictures with, it's about 3,000 years old. That's just a few years younger than most of our senators. Pretty darn old indeed. You might have noticed a few parts of the glacier were dirtier than others. That is moraines. These moraines are from when the glacier is advancing, scraping up against the mountains that it's in between, carving out large boulders. These large boulders will then be dragged across the land or against the mountains, being ground down to a fine rock flour. And that's why you see some ice that's a little bit dirtier than others. And then that ice, when it falls into the water, when it's deposited there, becomes a glacial silt. And that glacial silt is really important for the marine ecosystem out here. It has some really good nutrients like iron, phosphorus, and calcium. And at such a fine consistency, it's accessible to phytoplankton to use to grow in abundance here. And phytoplankton's the bottom of the food chain, folks. So if that prospers, everything else does as well. Now, we were really excited to see some calving events. Who here saw a calving event? Was everyone able to at least see one calving event? Very good. Who here heard a calving event? Very cool. So I know what you're thinking. You were really excited to see a calving event. It sounds like a few of you got it even on video, and it sounds like there is a very gracious man sharing them with people who weren't able to get it on their phone. But I know you're really excited to see it, but in your heart of hearts, you felt a little sad, right? It's like, this means that the glaciers are melting. Well, I have some good news and I have some bad news. We're going to start with the good news so we can end on a low note, because that's how my mom raised me, and that's why I have so many issues today. But the good news is calving events are a normal part of a glacier, whether it's retreating or advancing. There are two parts of a glacier. I mentioned the ice field is the accumulation zone. That's where snow falls and it builds up glacial ice. But then every glacier also has a melting zone at the face where we were just at. Even if a glacier is growing, gravity is still working on it, Air is still weakening it. Seawater, if it's a tidewater glacier, is eroding it. So there will always be calving events, even for a growing glacier. What causes a glacier to grow is it getting enough snowfall in the accumulation zone to build up glacial ice to compensate for what's being lost in the melting zone. So that's the good news. You don't have to feel guilty about the calving events. Here's what you do have to be sad about, is there isn't enough snow in this ice field to be able to build up glacial ice. And that's because temperatures have risen quite a bit in the last few decades, especially since 1997 here in Southeast Alaska. What used to be coming down as snow during the winter for the ice field to use as glacial ice is now coming down as a slushy rain. And again, it takes 100 inches of snow over 100 years to make 1 inch of glacial ice. So because of that, because the ice field isn't able to build enough glacial ice to compensate for what's being lost, it's in a state of retreat. That's why the area around the glacier, that was such pale rock, because that is very recently exposed deglaciated areas. In fact, if you take a look ahead of us, you see where that little ship is out where the fjord bottlenecks a little bit? That's where the face of Dawes Glacier was in 1985. There are consequences to glaciers retreating and glaciers melting at this rate. Obviously, there's a lot of ice that's on the land that's coming into the ocean. That can lead to rising sea levels. Also, all that fresh water coming off of the glacier coming into seawater is creating brackish water. And some animals can't live in brackish water. So a lot of the sea fish that are in open waters like Stevens Passage and out of this arm aren't coming up here because they can't live there. So as more water becomes brackish water, that means less habitats for these fish, which means less of a food source for many animals. This also means potentially the destabilization of ocean currents. Freshwater and saltwater don't mix. Freshwater rises above seawater. That's why there's a current coming off of Dawes glaciers, because the seawater is eroding the ice, causing freshwater to run up and rush up above the seawater, creating a current. With enough fresh water, that'll lead to the destabilization of ocean currents, which are responsible for weather patterns across the world. We could potentially see an increase of inclement weather around the world. So it's not just these coastal areas like Florida or California that have to worry about rising sea levels. It's everywhere. I don't know how to end that on like a happy note, like we're on a tour, let's have a good time note, but who saw those harbor seals? Everyone see a harbor seal? I heard a few of you on the deck, like, oh, look at the sea lions, or like, oh, look at the seals. I can't tell the difference. Do y'all know the difference between seals and sea lions? You want me to tell you the difference? All right, I want you to close your eyes and imagine 6 sea lions and then 6 seals. I don't know what those 6 sea lions can do, but those 6 seals took out Bin Laden. 2 clap for the troops. Okay, here's the real difference. They're both pinnipeds, which means winged feet. But sea lions typically are much larger. The Steller sea lions out in this area, the males get about 2,500 pounds. But the harbor seals in the area typically range from 150 to 300 pounds. Sea lions are very closely related to bears. That's their closest relative on land. So they have a bear-like skull and snout, while harbor seals have a bowling ball, more puppy dog shape to them. Harbor seals have little ear flaps, or sea lions have little ear flaps, harbor seals don't. Sea lions swim primarily with their pectoral flippers. Seals swim with their hind flippers. Seals have little fingernails or claws at the end of their flippers so they can hang on to ice. But my favorite difference comes down to their pelvic bone. If you've seen a seal on land, you'll notice that they're not on their flippers, they're on their belly. Because of that fused pelvic bone, those flippers can't support their weight. So if they want to move on land, they literally have to bounce on their bellies. It's called galumping. A sea lion has hip bones like us, so it can move fairly decently well on land. In fact, it can move so well on land that a Steller sea lion out here in Southeast Alaska can charge you at a speed of 15 miles per hour on land. That's faster than most folks can run. So pretty impressive indeed. Now, many of these harbor seals are relatively young here in Endicott Harbor. They just wrapped up their breeding season. So there's a good chance that the harbor seals that you were looking at today were about 3 months old. But even though they're so young, they are very independent. They're living life on their own, even if they're in a little group. These harbor seal pups, they only nurse for 2 weeks. Then after week 6, they are completely independent. When I came out and my mom saw that I was a redhead, she was kind of wishing I was a harbor seal. So she would only have to deal with me for 6 weeks. I miss her. But the harbor seals, they love the icy fjords of southeast Alaska. It's a good place for them to be able to rest and socialize, but all this ice in the water serves as a little safeguard between them and one of their biggest predators out here, killer whales. Now, killer whales, they hunt using vocalizations from their blowholes that travel through open waters. And once they hit an object, it'll bounce back, and they'll be able to gauge what they're looking at, even from relatively far distances. But from far distances, sometimes those images are a little bit blurry, so they go based off of size. So here, you'll notice that there were plenty of seals, but also a lot of seal-sized ice. So from distances, killer whales have a difficult time telling the difference between what's ice and what's a seal. So they typically don't come up here because there's a lot better and easier hunting to do in Stevens Passage, where there is much, much less ice. So these harbor seals are able to breed, socialize, and hunt without having to worry too much about killer whales.